All right, and welcome back. So today we are going to be talking about two-step, and then next time we're going to be talking about multi-step equations. But today we are going to be focusing all on two-step equations. So without further ado, let's begin. So to solve two-step equations, we're going to be jotting down the steps that we are generally going to be taking when we solve these two-step equations. So first things we're going to do is we're going to undo addition and subtraction. We're first going to undo addition and subtraction. After we undo addition and subtraction, we're going to undo our multiplication and division. So we're technically working backwards with our order of operations. Normally, when we're simplifying and solving, we're going to be going from parentheses, exponents, then we multiply or divide, and then we add or subtract. But when we're solving equations, we're going to be going backwards here. We want to be doing the opposites of what we would do if we're simply, well, simplifying. So let's put these two into an actual process here. Let's put it to an equation. Let's say we have negative 3x plus 7 is equal to negative 11. Well, if I look back up at our steps here, we're first going to undo addition and subtraction. Well, I see that I have negative 3x plus 7. So I'm just going to box in this negative 3x, the term that has the variable. That way visually I know I don't want to touch that term until I get everything else from that same side of the equal sign over and gone. Well, I have this plus 7, so to undo that, I have to subtract 7 on both sides. I eventually want this to turn into 0. Well, does 7 minus 7 turn into 0? You know it. So this cancels out, it turns into 0. And I subtract 7 on both sides because of what we do on one side, we do to the other. Well, I now drop down that minus 3x, or that negative 3x, pardon me. Now we have negative 11 minus 7 more, which means I now have negative 18. Well, pardon me. We undid our addition and subtraction. Now we're going to undo our multiplication or division. Well, I have negative 3x. It really says I have negative 3 times x. So to undo multiplication, just like we did with our one-step equations, we have to use division. So we're going to divide both sides by negative 3. That cancels out. That becomes 1. So now we're left with x is equal to negative 18 divided by negative 3. Well, I notice I have a negative divided by negative that turns into a positive. Now 18 divided by 3 is 6. Therefore, the solution to this equation is going to be 6. All right, great job so far, folks. Let's keep it rolling. Let's work with this problem here. So we have 4x plus 9 is equal to negative 7. Well, let's think back to our steps here. We first want to undo addition and subtraction. I'm also going to box in the term that has the variable. That way I know I'm not touching that term until it's all alone. Well, I see I have that plus 9. To undo addition, we have to subtract. So we subtract 9 on both sides. Again, we want this to turn into 0 because we want that 4x to be all by itself. Well, does 9 minus 9 turn into 0? Yeah, it does. So that cancels out. We're now left with 4x is equal to negative 7 minus 9 more gives me negative 16. Now, I want to undo multiplication or division. Well, I see I have multiplication. I have 4 times x. I'm going to divide both sides by 4. So now I'm left with x is equal to negative 16 divided by 4. I notice I have a negative divided by a positive. That gives me a negative. So I'm going to jot that down first. Now I know 16 divided by 4 gives me 4. So we end up with x being equal to negative 4. Let's check it though. Let's check. I'm going to go back to the OG. 4x plus 9 is equal to negative 7. We're going to substitute that value of x in, so that's 4 times, notice how I'm using parentheses, negative 4 plus 9 is equal to negative 7. Excuse me. We can simplify. 4 times negative 4 gives me negative 16 plus 9 is equal to negative 7. And lastly, we can simplify negative 16 plus 9 to give me negative 7. And is negative 7 equal to negative 7? Yes, it is, which means that this is correct. Awesome. Awesome job, folks. Let's do one more example. All right, we are going to solve and then check this problem out. I'm just going to shift it to make it easier for us. Okay, so I see I have x divided by negative 3. That quantity minus 4 is equal to negative 1. Well, I'm going to box in the term that has the variable in it. That way, again, visually I know I'm not touching that until everything else from that side of the equal sign is over on the other side. So I see I have this minus 4. To undo subtraction, we use addition. So again, I want this to turn into 0. Well, what's negative 4 plus 4? That goes to 0, so that cancels out. We now have x divided by negative 3 is now equal to negative 1 plus 4, which is positive 3. I now see I have x divided by negative 3. We also can say x over negative 3, but the proper term is x divided by negative 3 is equal to 3. To undo division, we have to multiply by whatever that denominator is. So I multiply by our denominator. Negative 3 divided by negative 3 turns out to be 1. So we just have 1x. And now we have 3 times negative 3. Well, a positive times a negative is a negative. 3 times 3 is 9. Therefore, we get x is equal to negative 9. And let's check it to make sure that it actually works. Okay, we go back to our OG. We're going to substitute in the value of x. So I got negative 9 divided by negative 3 minus 4 is equal to negative 1. Let's think about our integer rules here. A negative divided by a negative turns into a positive. 9 divided by 3 turns into 3. So we have 3 minus 4 is equal to negative 1. Well, 3 minus 4 gives me negative 1. So is negative 1 equal to negative 1? Yes, it is, which makes our answer of x equals negative 9 correct. Awesome. Sweet. Excuse me. Let's try one more, and I want you to try this one all on your own. So please pause the video, attempt the problem, and then resume when you are ready to watch the answer unfold. All right, so if you're listening to my voice, that means that you attempted this problem and you are here to check your answer and to check that you checked your answer correct. So the first thing I notice is I have this term of negative 4x. I'm going to box that in. That way I know I'm not operating with it yet. I want to undo this addition by subtraction. What I do to one side, I do to the other. This goes to 0, which is perfect. Negative 21 minus 7 more turns into negative 28. Is now equal to 4x. I drop everything else down. Well, I want that x all by itself. I have negative 4, so I have to divide by the entire coefficient. Notice how that coefficient is a negative, so I'm dividing by the negative. That cancels out. Negative 28 divided by negative 4. Well, a negative divided by a negative is a positive. 28 divided by 4 is 7. So I get that x is equal to 7. Or 7 is equal to x. These two are the exact same. It's like saying 2 plus 2 is equal to 4 and 4 is equal to 2 plus 2. They're the same. Typically, we have our variable on the left-hand side equaling the solution. But if you have the solution equals a variable, you're not wrong. Those are the exact same here. So now we're going to go back to our check. And now let's plug it back into the OG. Negative 21 is equal to negative 4x plus 7. We're now going to substitute in our value of 7 for x. We have negative 21 is equal to negative 4. I'm going to use parentheses here. Oh, sorry. We're going to simplify our multiplication. So negative 4 times positive 7 is now negative 28. Drop everything else down. And now we're going to simplify. So we have negative 28 plus 7 gives me negative 21. Let me do this in a different color. Well, is negative 21 equal to negative 21? Yes, it is, which makes our solution of x being 7 correct. Great job, folks. If you have any questions, feel free to reach out, but great job so far.